Welcome to my video on DNS. Today we're going to be covering a few different facets of DNS and how they work. I want to start the video with name resolution and how it's accomplished using the root servers on the internet and on your network. So, the way name resolution works, let's say I am on my network, which is right here, and I'm on this workstation, and I type in www.google.com into my browser. My browser then sends a request to my workstation's resolver, and it sends it through here into my DNS server, which just so happens to be server 10, to his resolver. Now, this is when the work starts. The only way the work is actually going to start is if this DNS machine is doing recursion. Otherwise, my DNS machine will only look to its own root and say, I don't know the IP address for google.com, and send me an error back to my workstation. With recursion enabled, on the other hand, my DNS machine will say, I don't know the IP address for www.google.com, but I do know where the root servers are out on the internet. Now my resolver starts doing recursion. Goes all the way through here, through this bridge, into my gateway, and out to the internet, over to here to the root servers, and says, hey, do you know where www.google.com is? The root server responds, I don't, but I do know where the .com servers are. So he sends that answer all the way back to my server 10 right here, to his resolver, and he says, all right, I'm going to go ask the .com servers. So he goes all the way back out and says to the .com servers, hey, do you guys know where www.google.com is? And they say, no, I don't know where www.google.com is, but I do know where the google.com servers are. Sends that all the way back to my machine, to this resolver. These servers are the authoritative servers for google.com. So when my resolver sends a request to the google.com servers, they are not doing recursion, but they can look inside their own little directories and say, hey, I know exactly where www.google.com is, and he gives me an IP address for www.google.com. Now, I can finally take that answer from this resolver back to my workstation's resolver and to the browser. Now, the browser is able to build a GET packet and then sends it to the IP address that he just received, presumably www.google.com's IP address. Now, the IP address has a web server, hopefully, and it pulls up the info that I asked for, sends it back to my browser, and magically up pops a web page. The next thing that I want to talk about are forward and reverse lookup zones. Forward lookup queries request the IP address that corresponds to a fully qualified domain name. For instance, if you type in www.google.com, it will return the IP address like I explained in the previous example. Now, a reverse lookup returns the fully qualified domain name of a host based on its IP address. So if you typed in the IP address of Google, it would send you back www.google.com. Now, let's talk about the different types of zone transfers. First of all, what is a zone transfer? Well, a zone transfer is the way that changes in the primary DNS zone get updated in the secondary DNS zones, or the copy zones. There are three different types of zone transfers. The first is a full zone transfer. The way a full zone transfer works is the master server, or the primary server, for a zone transmits the entire database to the secondary server for that zone. The next type of zone transfer is called an incremental zone transfer. With an incremental zone transfer, only the modified part of the zone must be transferred. As you can imagine, an incremental zone transfer is generally much more effective and requires less bandwidth to accomplish. Now, these two types of zone transfers are accomplished in just about the same way. The way it works is the secondary server for the zone waits a certain amount of time, specified by the refresh in the SOA record, Start of Authority record, we'll talk about that later, and then pulls the master server for its Start of Authority. The master server for the zone responds with the Start of Authority resource record. The secondary server for the zone compares the returned serial number to its own serial number of the record. If the serial number sent by the master server is higher than its own serial number, that means the secondary zone is out of date. It then sends a request. Now, for a full zone transfer, it's called an AXFR, and for an incremental zone transfer, it would send an IXFR request. The final type of zone transfer also covers another topic that I want to talk about, which is Active Directory integration. Now, the third type of zone transfer is called Active Directory replication. Replication is the way changes on one domain controller are updated with all other domain controllers on the domain. Active Directory replication uses a connection topology that is created automatically, which makes optimal use of beneficial network connections and frees the administrators from having to make such decisions. Active Directory integration also enables Active Directory storage and replication of DNS zone databases. This only works on an Active Directory domain controller, but it is very beneficial for managing different sections of your DNS. The next segment that I want to talk about is the difference between forwarders and caching DNS servers. A caching DNS server is a server that handles recursive requests from clients such as the one in my example, server 10. The beneficial parts of having a caching DNS server is it gives you access to the entire range of public DNS data. It also knows all about the root servers and can intelligently follow referrals as it receives data, just like I described in that first example. It can also maintain a cache of recently requested data. By caching the results as it collects them from other DNS servers for its clients, a caching DNS server builds a cache for recent DNS data. Depending on how many clients use the server and how large the cache is, this drastically speeds up DNS resolution in most cases. A forwarding DNS server, on the other hand, has the following properties: the ability to handle recursive requests without performing recursion itself, such as the authoritative servers that Google used in our original example. The most fundamental property of a forwarding DNS server is that it passes requests on to another agent for resolution. The forwarding server can have minimal resources and still provide great value by leveraging its cache. It also provides a local cache at a closer network connection. This can decrease answer times for clients in close proximity. It also increases flexibility in defining local domain space. By passing different requests to servers conditionally, a forwarding server can ensure that internal requests are served by a private server, while the external requests use public DNS. The The next topic that I want to talk about is called dynamic DNS. DNS client computers can use dynamic updates to register and dynamically update their resource records with a DNS server whenever changes occur. This reduces the need for manual administration of DNS zones, especially for clients that frequently move or change locations and use DHCP, Dynamic Host Configuration Protocol, to obtain an IP address. Dynamic DNS also applies to Active Directory integrated DNS. This next topic is also going to be a short one about providing redundancy in your DNS servers. The best way to provide redundancy is building failover pools, so it can automate failing over from the primary server to the backup server in case the primary server goes down. From what I've found online, it's best to have 4 to 6 IP addresses in these failover pools to ensure that your DNS server will be resilient under an attack and have a lower chance of going down. The final topic that I want to talk about are the different types of DNS records. Now, there are a ton of these, so to make it easy, I'm just going to read off some definitions that I found at technet.microsoft.com, which is where I got most of my information for this video. I also got some other information from digitalocean.com and from my classes at the college. Now, let's get started on these different types of DNS records. The first one is called an A record, or an address mapping record. The A record specifies an IP address for a given host using IPv4. The records are used for conversion of domain names to corresponding IP addresses. The next one is AAAA records, and those are the same as an A record, except for it's the IPv6 version. The next is called a CNAME record. CNAME record specifies a domain name that has to be queried in order to resolve the original DNS query. Basically, that's a fancy way of saying it's an alias that corresponds to an A record or an AAAA record that's already in existence. The next one is called a HINFO record, host information record. These are used to acquire general information about a host. The record specifies type of CPU and OS. HINFO record data provides the possibility to use operating system specific protocols when two hosts want to communicate. Next, we have ISDN records, Integrated Services Digital Network records. The ISDN resource record specifies ISDN address for a host. An ISDN address is a telephone number that consists of a country code, a national destination code, an ISDN subscriber number, and, optionally, an ISDN subaddress, if it's applicable. The function of the record is a simple variation of the A resource record function. The next type of record is called a mail exchanger record, or an MX record. The MX record specifies a mail exchange server for a DNS domain name. The information is used by SMTP, Simple Mail Transfer Protocol, which is email. Typically, there are more than one mail exchange server on a DNS domain, and each of them have a different set priority. The next type of record is called a name server record, or an NS record. The NS record specifies an authoritative name server for a given host. Next, we have reverse lookup pointer records, PTR records. A PTR record is used to look up domain names based on an IP address, basically the opposite of A or AAAA records. The next is called a start of authority record, SOA, which we talked about earlier. The SOA record specifies core information about a DNS zone. including the primary name server, the email of the domain administrator, the domain serial number, and several timers relating to refreshing that zone. The final type of record is called a text record, or TXT. The text record can hold arbitrary non-formatted text string. Typically, the record is used by Sender Policy Framework, SPF, to prevent fake emails to appear to be sent by you. Thank you for watching. This concludes my video on DNS. I hope you learned something and didn't get too bored. Have a lovely day.